Hello everybody, my name is Mike Geig, and in this video we are going to be looking at distance-based collision detection in Allegro 5. Now for starters, we are going to use the code that we worked on in the previous video. So if you haven't watched that, go ahead and do that. But we're going to kind of be starting where we left off to save ourselves some typing. In this video we're looking at distance-based collision detection, which effectively means that we are going to be comparing the center of our images, the X and Y positions, against each other, and if they're close enough, we can assume they've collided with each other. This has a large benefit when working with, say, spheres or circles, because we're going to work with a radius. And it seems that just naturally fits together. However, very much like how bounding rectangles didn't necessarily work so well with circles, the distance-based, or you can call it a radius-based collision detection, doesn't work so well with rectangles. We have the corners and stuff like that kind of get cut off and aren't accurately detected. So it's another way of doing it. However, you're going to see that if you're using rectangles, this algorithm has its shortcomings, just as like you were using the bounding rectangles on a circular image. One thing I do want to know before we start, I have included the math.h library. We're going to be doing some square rooting in some math.pow, so I have that in there. So just make sure you have that in there. I've also modified the sprite struct. I no longer have bx and by. I now just have r, which is my radius, and we'll see that everything else is pretty much normal. I've just removed the code that doesn't apply anymore. So I'm still defining my x and y position. I'm still loading in my images. I'm still figuring out my width and height. I am still moving my objects around, and I'm still drawing my bitmaps. I'm just not drawing a bounding box. Alright, so let's go ahead and run it so you can see where we're at. And no bounding box, so hitting space doesn't do anything. No collision detection, but everything's still where we left it. Alright, great. So the first thing I want to do is I want to dictate the size or the radius of my images, very much like I did with my bounding box. Alright, and we'll do it just the same way we did last time, so that we can see the shortcomings and we can tweak from there. So I'm going to start with ball1.radius, and I'm just going to pick ball1.width divided by 2. I could have done height. I could have tested to see which one was the biggest and used that one. But for simplicity's sake, I'm just using the width. Ball2.width divided by 2. Okay. So that'll define our radius for us, and then we can use that to dictate all of the other good stuff. So let me come down to my render section. Before I do my collision, I want to draw out my bounding. Well, this time bounding circles, because we're not necessarily using bounding boxes in a distance-based collision detection. I'm going to do AL, draw, build, circle. And I'm going to pass in my points. It's going to be ball1.x, ball1.y, my radius, ball1.r, and my color. AL, map, RGBA underscore F, 0.6, comma 0, comma 0.6, comma 0.6. I will copy this line, paste it, and change all the 1s to 2s. Alright, great. And I'll run it real quick just to give us an update here. And we can see our bounding rectangle, or our bounding circles. You can see too the circle is way bigger than the orb. So right off the bat, we know we're going to have a lot of false positives with this until we adjust. But all in good time. We'll work on that here in a second. I want to get my collision detection algorithm written up first. So basically, what we want to do is we want to figure out how far the images are from each other currently. So the X and Y values of each image. And using that information, we're going to determine, is it so close that they have to be touching mathematically? Alright, so what I want to do is I want to go ahead and figure out the distance between my images using a little bit of vector math here. So what I'm going to do is create a variable, float distance. And what I want to do is I want to run the formula for calculating the distance between two vectors. And that is going to be sqrt square root. Alright, and let me just open this up here. We'll condense it back down in a second. So I want to raise something to the power of 2. So I'm just going to use the pow function for that. I'm going to do pow ball1 dot x minus ball2 dot x. Okay, and I'm going to raise that to the second power. Alright, and then plus pow ball1 dot y minus ball2 dot y. Raise that to the second power. And there we go. So that is the equation. We're going to do x1 minus x2 squared plus y1 minus y2 squared, and then square root the whole thing. Let me just condense this back down now that we have it right. It'll also help you get all your parentheses and everything right. Okay, so that will give me the distance between two vectors in a scalar value. And so now all I have to do is I need to test that distance to see if it's too close. So I'm going to say if distance is less than ball1.radius plus ball2.radius. If that's the case, then I know collision is true. Else, collision is false. Oh, right. So let's run it. Now let's give it a whirl. So I've got my bounding circles, and then bam, collision is true. Collision is true. Collision is true. Collision is true. So you can see all the way around the circle, we can have accurate circular collision detection based on the distance between the center of the items. But let's go ahead and modify our radius values here a little bit. So I'm going to come back up here, and we did 10 for our bounding boxes before. We'll try that again. It might be too much. Let's give it a whirl. So we're going to do minus 10 on that, and we're going to see, oh wow, look at that. That is just dead on. Just about perfect. So you can see we're not getting a whole lot of false positives. The second they touch, we're pretty much rendering collision. The one downside, and this is the reason I made this image look like this, is you can see we're rendering collision here, even though we're obviously not colliding. But based on our distance calculations, we are rendering a collision. So just kind of a shortcoming of this algorithm. Still great to use when you're using circles, especially in games where your items are moving fast. No one will really ever see that level of inaccuracy, depending on your game. But if the object's moving even remotely fast, your eye just won't pick it out. So distance-based collision detection is great if you're using circles, or like say you're firing orbs at something or whatever. So just keep that one in mind. But it has its limitations if you're using rectangles or if you are doing odd shapes. You know, right now so far we've been dealing with rectangles and circles. And if we have an odd shape, like I would consider this item on our screen to be an odd shape, we have some shortcomings with some inaccuracies. In the next video, we're going to look at a new way of doing collision detection, which will resolve the shortcomings of these two collision detection methods, but it comes with a little bit of a price. So stay tuned.